bond order, bond length, and bond strength. So before we start drawing Lewis structures, we just have a couple more small topics to discuss. And the first of these is bond order. And this is a relatively straightforward concept where the bond order gives the number of bonds between two atoms in a molecule. Now, atoms can form molecules where they have single bonds. Okay, so you can see that these two carbons are bonded together with one bond. We call that a single bond. They can bond together with something called a double bond. So that's one of the multiple bonds, or a triple bond. Each of these bonds in all of these molecules, each line represents 2 electrons, okay? So this carbon-oxygen bond involves sharing 4 electrons. This carbon-oxygen bond involves sharing 6 electrons. And of course, the carbon-carbon bond in ethane is 2 electrons shared, and we've seen quite a few examples of that. So the carbon-carbon bond in ethane is a single bond. So you're going to hear that, or you're going to hear the bond order is equal to 1. Okay, so as I said, a relatively straightforward concept. If the bond order is 1, then it's a single bond. And that means that 2 electrons are shared between those atoms involved in the bond. Now, these carbon-hydrogen bonds are also single bonds. So the bond order is 1 between carbon and each hydrogen. Now, carbon dioxide has double bonds. And so here we have carbon bonded to oxygen with a double bond. That's 4 electrons being shared, and the bond order is 2. All right, a carbon-oxygen bond in carbon monoxide is called a triple bond. And 6 electrons are shared, and the bond order is equal to 3. Now, I haven't shown it on this video, but once we start talking about resonance, we're going to see that bond orders don't have to be a whole number. They can be fractions, and so we'll see that later on. But right now, what you need to keep in mind are single bonds, double bonds, and triple bonds. Okay, now bond lengths and bond strengths are both related to the bond order. So here is a chart showing a single bond between carbon atoms, a double bond between carbon atoms, and a triple bond. And you can see also the bond order is 1, 2, and 3, respectively, for each one of those. And then what I would like you to do is look at this chart and take note of the trends that you see with bond order and bond length, and bond order and bond strength. So bond dissociation energy is the amount of energy that is required to break that bond. If you haven't done it already, pause the presentation and look at this chart. And what I would like you to do is to come up with a rule for each bond length with bond order and bond strength with bond order. So remember, the bond strength relates to the bond dissociation energy that you see in the last column. So pause the presentation and try to write a couple of rules. Okay, so there's a couple of different ways that we can say this, and you might have said it a little bit differently, and that's okay too. The higher the bond order, the stronger the bond. So a triple bond is stronger than a double bond, which is stronger than a single bond. Also, the higher the bond order, the shorter the bond. So if the bond order is 3, that bond is going to be shorter than a bond order of 1, which would be a single bond. So triple bonds are shorter than single bonds. Another way that you might have said it is that bond length decreases with increasing bond order. So again, bonds get shorter as the bond order increases, and bonds also get stronger as the bond order increases. Okay, so the next thing we're going to talk about is formal charge, and we will be ready to draw Lewis structures.